So when you're examining Lenz's law, there's some great demonstrations you can make up. You can make up quite pretty neat ones, or you can use quite beautifully constructed ones out of pieces of stuff from around your laboratory and home. One of the simplest ones to make up is looking at having one of your stronger rare earth magnets and a piece of aluminium, which you can easily purchase at a hardware store. The thicker the aluminium, the better, because the eddy currents that form in it, the deeper it is, the better it will actually work. So one this thickness, quite easy to use, and then you can get the students to slide this down it and bring it up and up and up, and something really strange happens. You can also get the students then to say, well, hang on, it doesn't stick to it at all. What's going on? And then you can ask the students just to wave it over the top, so there's about 1 millimetre between the top there, and feel that there's a drag on it. This can be an ideal introduction to eddy currents and Lenz's law. What you can then do, just to get the students really thinking, is make up some little combs. These can be high-tech made things like this that one of the students has made in a workshop for me and cut down, make a comb like this, or the comb could have been easily made out of an aluminium can that had actually been flattened out and then just cut with a pair of cutters down just to make that same sort of thing. What I find really nice about making up one of these for more of a permanent demonstration is we can do the same trick that we did with the other one. And this time we can do a predict, observe, explain, and ask the students after they've examined it sliding down a solid plate, what would happen as it slid across or down the actual combs. So we can have a look at that. It just slides off. It doesn't go slow at all. And they always say, well, it's made from something different, sir. Well, always leave enough down this side here to clearly demonstrate it is not different. Of course, there's the other two fantastic experiments you can do. It's a piece of aluminium pipe, put the magnet in the end and let it go. It looks fantastic from the top, and you hear it slowly tinkle down and pop out the bottom. You're exploring eddy currents in this again, and the students after a while get the idea that an eddy current's forming here. But what's really interesting about this is get them to visualise and then also draw what is happening, a side-on view of what's actually happening with the currents within the pipe on either side and the orientation of the magnet. If you hold the pipe at a slight angle and let it go, it'll often roll down the pipe like this, but still goes slowly when it tinkles down. And you can ask them what's going on with that. And of course, after they've all got very smart, you can ask them about what will happen if you drop it down a pipe with a slot on the side of it, and do a predict, observe, explain on that. It was still slower, but things had changed with this. You notice with this pipe, I bought one that was quite a thick walled pipe. If you use a thinner walled pipe, different things happen. Once the students are total geniuses, of course, give them a piece of this. It's non-magnetic, it's metal, conducts electricity, put it in the end of the pipe, falls straight out the end. And you have to ask them, why would this pipe act differently to this pipe? This is steel, this is aluminium.